We're going to do one example to practice dividing using long division, and then we're going to talk about dividing using synthetic division. So let's go to the one we left off on. I think it was on page 7. This one. So we put the divisor, the little one, outside the box. So it'll be x squared. We have to be careful here because we need each term represented. So if I start with x to the second power, I also need a 0x, x to the first power. So I'm going to say plus 0x plus 3. Now inside the box, am I missing any terms? What? X squared. So in that spot, I'm going to put a 0x squared. So now I have x to the third power, x squared, x to the first power, constant. So if you start with whatever degree you start with, let's say x to the fourth power, you need x to the third power, second power, first power. You need each term represented. So inside the box, we have 2x to the third power plus 0x squared minus x minus 7. Now let's see who remembers from yesterday. What's step 1? Divide. We start by dividing. What is 2x to the third power divided by x squared? 2x. Awesome. So I'm going to put that on top of my x term. Now we multiply. Step 2. Multiply. So 2x times x squared would be 2x to the third power. What's 2x times 0x? 0x squared. So I'm just going to keep that in line. And then 2x times 3? 6x. What is step 3? Change the signs and combine. Awesome. So we change the signs of all 3 things in this step. And combine. The first ones are always going to cancel if you did it right. What's 0x squared minus 0x squared? 0. So that one cancels too. It's still 0. And then what is negative x minus 6x? Negative 7x. All right. From here, we start all over. So go back to step 1, we divide. I have negative 7x divided by x squared. Can I divide negative 7x by x squared? Do I have 2 x's that I could take away? No. So what do you think I'm left with? The remainder. Once you can't divide anymore, what you have left is the remainder. So our remainder is negative 7x. What else? Minus 7, because we still have that minus 7 there. So we can write our remainder a couple different ways. On the big idea is it wants you to write it as a fraction. So 2x, you could say plus negative 7x minus 7 over our divisor, which was x squared plus 3. Or I talked about it in the video how since both of these have a negative, we can pull that negative out and make it 2x minus 7x plus 7 over x squared plus 3. So we're pulling the negative out from the top and just turning it into a minus. So either one of these would be fine as an answer. Big ideas might want it this way, the second way. You can always check your work. So this is checking of example 4. You can check the result of a division problem by multiplying the quotient by the divisor and adding the remainder to it. So this is one way that you can check. If you had time on a test and wanted to check, you can check by multiplying the quotient and the divisor and then adding the remainder. All right, part 2, we're going to talk about synthetic division. So synthetic division is a shortcut for dividing polynomials. So we're going to walk through the first couple together so you see the strategy, but once we do a couple, you'll see this is so much easier than long division. Synthetic division. So we're going to make a box upside down from the box that we drew before. So instead of a dividing box, we're going to flip it, make box upside down. Outside the box, we put our divisor, but just the number, and we always change the sign. So we would put a positive 3 outside the box. Inside the box, we put the coefficients of our dividend, the long one, what we're dividing into. But just like before, we have to make sure all of our terms are represented. So am I missing any terms here? An x. I have an x to the third power, x to the second power. I'm missing x to the first power. So in this spot, I'm going to put a 0x. Now I'm going to put the coefficients of each of these. So in the box, I'm going to put a -1, 4, 0, and 9. Now the first step is to drop down the first number inside the box. So -1 goes on the outside. Now outside the box, we multiply. So what is 3 times -1? -3. Inside the box, we add. So what is 4 minus 3? 1. Now outside the box, we multiply. 3 times 1? 3. Inside the box, we add 0 plus 3? 3. Outside the box, we multiply. 3 times 3? 9. Inside, we add 9 plus 9? 18. Now these numbers here are coefficients of our answer. If I started with x to the third power and I took 1x away, my answer is going to start with x to the second power. So this is going to be -1 x squared plus x plus 3 with our remainder of 18. So to rewrite that a little bit better, we have -x squared plus x plus 3. How would I write my remainder here? Awesome. As a fraction, plus 18 over x minus 2. Our remainder over our divisor. Oh, x minus 3. Sorry. It is way easier than the long way, but you have to know both ways. All right, example 3. So I'm going to draw my box. What's going to go outside the box? -1. Remember, we changed the sign. So -1 goes outside the box. What's going to go inside the box? Awesome. 3, -2, +2, and -5. So we write our coefficients inside the box and keep the signs that go with it. All right. Now that we have it set up, what's step 1? Before we multiply, what do we have to do first?
Put it outside the box.
We drop the 3 down outside. What's next? Then we multiply. -1 times 3? -3. Then what? Add inside the box. -2 minus 3? -5. -5 times -1? +5. 5 plus 2? 7. 7 times -1? -7. And -5 minus 7? -12. Be very careful when doing the math here. If you make a mistake in the beginning, it's going to throw all your numbers off for the rest of the problem. So just be careful. If my question starts with x to the third power, what's my answer going to start with? X to the second power, so 3x to the second power minus 5x to the first power plus 7 is our constant, and negative 12 would be our remainder. So 3x squared minus 5x plus 7. How would I write my remainder? So minus 12 over x plus 1. So divide using synthetic division. What's going to go outside the box? Negative 3. Don't forget, we changed the sign. So negative 3 outside. What's going to go inside the box?
Oh, wait, I'm looking at the wrong column.
2, 1 is negative 7.
Be careful. Are we missing anything?
Oh, we're missing the zero.
We're missing the x squared, so I have to put a 0 in the x squared spot. So what's going to go inside the box?
2, 0, negative 1, negative 7.
Perfect. What do I do first? Drop down the 2. What do I do on the outside? Multiply. Negative 3 times 2. Negative 6. 0 minus 6. Negative 6. Negative 6 times negative 3. Positive 18. Negative 1 plus 18. 17. Negative 3 times 17. Let's write it down. 17 times 3.
No, it's not 84. What is it?
51. Negative 51. And negative 51 minus 7. Negative 58. All right, if my question starts with x to the third power, what's my answer going to start with? X to the second minus 6x plus 17. Remainder is negative 58. So let's write that a little bit better. We have 2x squared minus 6x plus 17. How would I write the remainder? So I'd say minus 58 over x plus 3. Since it's a negative, I'd write minus instead. All right, so part 3, we're going to talk about the remainder theorem. So the remainder theorem tells you that synthetic division can be used to evaluate a polynomial function. So we're going to use synthetic division to evaluate. So I'm going to jump right into the first example so we can see it a little bit better. So example 4. It says evaluate when x is equal to negative 4. Gavin, on the last quiz that we had, we would take negative 4 and plug it into the x's to solve. Remember doing that? There's a different way that we can do that and find the same answer. So that's called the remainder theorem. So remainder theorem, the remainder is going to be our answer. So we're going to use synthetic division. Here, when it says x is equal to, you don't change the sign. So x is equal to, it's going to tell you exactly what to put on the outside. We're going to put negative 4. So don't change the sign when it says x is equal to. What's going to go inside the box?
5, negative 1, 13, and 29.
Perfect. 5, negative 1, 13, 29. So we drop down the 5. Thank you. Then what do? Multiply. Negative 4 times 5 is? Negative 20 minus 1. Negative 21 times negative 4. Let's write it down. 21 times 4 would be 84. Positive 84. Then we add. We get 97. 97 times negative 4. 7 times 4 would be 28. 388. Negative 388. And negative 388 plus 29.
Negative 359.
Negative 359. Now, for our solving ones, when it says evaluate, just the remainder is our answer. So when x is equal to negative 4, if I plugged it in, I get negative 359. If you want to, plug it into all the x's and evaluate it that way, and you'll get the same thing. It'll be a little bit longer, a little bit more work when you plug it into each number. So synthetic division is kind of like a shortcut to evaluate. So f of negative 4, when I plug negative 4 into the x's, I get negative 359. On the next page, it says the same thing that I just said. You can check your work by substituting in x is equal to negative 4 into the original function. So you can plug in the negative 4 into the x's, and you'll end up with the same answer. All right, let's do the last two. Tuesday. What's going to go outside the box? 5. Remember, when it's x is equal to, we don't change the sign. If it says x is equal, it's telling you exactly what to put in the outside. What do we put on the inside? 4, negative 10, negative 21. Awesome. We start with x squared. So we have x to the second power, x to the first power, constant. So we're not missing anything here. We're going to drop down the 4. What do we do on the outside? Multiply. 5 times 4 is? Negative 10 plus 20. 10. 5 times 10. And 50 minus 21. 29. So what would our answer here be?
29.
Awesome. Just the remainder. So f of 5, when we plug in 5, we get 29.
So, like, how would you know when? Oh, wait, no, you just say it in the question. Like,
Yeah, it'll say it in the question. The instructions will say, use synthetic divisions to evaluate. When you're evaluating, your answer is just going to be one number. If it said use synthetic division to divide, you need the whole thing with the x's.
And when you're writing your remainder, you just put the remainder over the first thing?
Yeah.
Like, would you put that over 5 or over x equals 5?
Well, when it asks you to divide using synthetic division, it would say like x minus 5.
Oh, okay, it's not.
It'd write it differently. Right.
Okay, thank you.
Number 6. What's going to go outside the box here? 2. What goes inside the box?
5, 2, 0, x. I mean, no, 0, and then another 0, and then negative 10.
So what are we missing here? The x squared. So in that spot, I'm going to put a 0 for the x squared. So I put 5, 2, 0, negative 20, and negative 6. What do we do first? Drop down the 5. What do we do next? Multiply. You get 10. 2 plus 10? 12. 12 times 2? 24 plus 0? 24 times 2? 48. 48 minus 20 would be 28. 28 times 2? 56. And 56 minus 6? 50. So what's our answer? When we plug in 2, what do we get? 50, just the remainder.